Hello guys, our lesson for today is Sandwich Theorem. Now in this video we will study the Sandwich Theorem, also called the Squeeze Theorem. This theorem helps us find limits when a function is trapped or squeezed between two simpler functions. Now what does the Sandwich Theorem state? If we have, suppose you have three functions, h of x, g of x, and f of x, where g of x is between h of x and f of x when x is near a. So when x approaches a, g is between h and f. F of x and h of x approach to the same limit L, or have the same limit L as x approaches a. Then, as a result, the limit of the function g of x squeezed between the two functions h and f will be equal to L as well. So if you look at the graph, the green curve is f, the blue curve is h, and the red curve between them is g. Notice that g is always between f and h. So as x approaches a, both the top and the bottom curves f and h approach L. So as x approaches a, f and h approach L. So the middle curve g has no choice but to approach L as well. Now the key idea here that if a function is squeezed between two functions that have the same limit or that meet at the same limit, then it must also meet them at the same limit too. Example, now we have f of x between 3 of x and x cubed plus 2. We need to find the limit of f of x as x tends to 1, or as x approaches 1. Let's find the limit first of 3 of x. So as x approaches 1, the limit of 3x as x approaches 1 is equal to 3 times 1, it is equal to 3. Now the limit of x cubed plus 2, x cubed plus 2 as x approaches 1 is equal to 1 cubed plus 2 is equal also to 3. Now since f of x is between 3x and x cubed plus 2, so and both limits are equal, the limit of 3x is 3, the limit of x cubed plus 2 is 3 as x approaches 1. So here the sandwich theorem applies, and so by sandwich theorem the limit of f of x as x approaches 1 is equal to 3. Now the sandwich theorem is especially useful when direct substitution does not work. So inequalities here help us trap the limit of the function. Show that the limit of t squared sine 1 over t is equal to 0. Now let's study the second example using the sandwich theorem. This example involves a trigonometric function and cannot be solved by direct substitution. So let's start by a basic trigonometric inequality, which is sine x, here sine 1 over t. Sine 1 over t is always between -1 and 1 for all real values. Now we need to find the limit as t tends to 0 or approaches 0 for t squared sine 1 over t. So let's multiply the whole inequality by t squared to get minus t squared less than t squared sine 1 over t, t squared. Since t squared is always non-negative, so the direction of the inequality does not change. Now we have t squared sine 1 over t is trapped between two functions, minus t squared and t squared. So let's compute the limits of the two outer functions. the limit now as t approaches 0 of negative t squared is equal to 0. Also the limit as t approaches 0 of t squared is also equal to 0. Since both outer limits are equal to 0 and the function is between them or strapped between these two functions, then the sandwich theorem applies. Therefore, the limit for t squared sine 1 out of t as t approaches 0 is equal to 0. Now look at the curve. The lower curve here is minus t squared. The upper curve is t squared. The oscillating curve between them is t squared sine 1 out of t. Even though sine 1 out of t oscillates and has no limit as t approaches 0, but multiplying it by t squared forces the entire expression to approach 0.